Good morning, students. I am Dr. P.S. Kaushik, Principal at Sri Digambar Institute of Technology, Dosa, Rajasthan. I am taking this subject engineering mechanics, which belongs to civil and mechanical third semester of RTU. This is my fifth lecture on this. Let us learn what we have learned in the last lecture. We learned in the last lecture the system of forces of force system, principle of independence of forces, that is which brings the concept of resultant force, and principle of transmissibility. Here, as I told you in the last lecture, a system is the one in which two or more identities work together for a common goal. Here, system of forces means where more than one force act together on a body. Here in engineering mechanics we have considered the body as a rigid body. This you should understand when you are dealing with any of the problems of engineering mechanics. ठीक है, तो सिस्टम ऑफ फोर्सेस दे आर कोप्लेनर फोर्सेस एंड नॉन कोप्लेनर उसको हम स्पाइटल फोर्सेस भी कहते हैं. Then coplanar forces are further divided into three, that is cone current. Cone current means they are meeting at a common point. Their line of action meets at common point. Then parallel force, then non-cone current, non-parallel forces. Non-coplanar or spital forces, that is cone current, parallel, non-cone current, non-parallel. Then cone current forces are further, that is coplanar cone current forces are further divided into like forces and unlike forces. Then principle of physical independence of forces, that is concept of resultant force. Here we say that if a body is acted upon by a system of forces, then that system of forces can be replaced by a single force which will have the same effect as the system of forces. That single force will be called resultant, but its four characteristics are to be clearly defined, that is magnitude, point of application, line of action and direction. Then we studied the principle of transmissibility. This is a principle, not a law. Why it is principle? We can say because it is applicable only on the rigid bodies. So we can define it, explain it with the help of principle of superposition. What it states? It states simply that if we keep the magnitude, line of action and direction of the force constant, and if we change its position, that is point of application, on the body, then its effect on the body will remain same. Here the principle of superposition explains it as below, that a force F1 is acting at point A. We want to change it to point B. What we have done? We have applied the two forces equal and opposite of the same magnitude as of acting at A in figure 2, and just we cancelled the two forces, that is initial F1 force at A and the opposing force at F2 at B, that is, and just the net force left is F1 at B. So it has changed the position, but without changing its effect on the body. Now let us proceed further. That is equilibrium, resultant and equivalent. These are the three topics I am going to cover in this lecture, and we will take on 2-3 problems on this. But before that, you should understand the parallelogram law of forces. because I will define these three on the basis of this figure only. जैसे कि पैरेललोग्राम लॉ ऑफ फोर्सेस क्या स्टेट करता है? इट स्टेट दैट इफ टू concurrent forces P and Q are acting on a body, then the resultant is given in magnitude and direction by the diagonal of a parallelogram made by these two forces, and that diagonal is passing to the point of concurrency of these two forces. So refer, there are two forces P and Q. We have drawn them by taking a proper scale, that OA and OB, and we have sketched a parallelogram, that is OBCA, and its diagonal OC is the resultant. It can be proved very simply. Just drop a perpendicular from C on OA extended to D. Then CD is equal to Q sin theta, because OB and OC are parallel. So in magnitude they will be same. Then OD is equal to OA plus AD, that is OA is equal to P, AD is equal to Q cos theta. So OD equal to P plus Q cos theta. From right angle triangle ODC, by using Pythagoras theorem, we can say OC square equal to OD square plus DC square, or OC we have defined R. So R square equal to P plus Q cos theta square plus Q sin theta square. Just rearranging them, and we find that R equal to under root of P square plus Q square plus 2PQ cos theta. The angle alpha is given by Q sin tan alpha equal to Q sin theta upon P plus Q cos theta. Again applying the Pythagoras theorem. Now sign convention, you should know that the horizontal forces will be positive when these are to the right of O, that is from 270 degree to 90 degree, and 90 to 270, that is toward left, this will be negative. Similarly vertical forces will be, that is above O, or will be positive from 0 to 180 degree, and then these will be negative in the third and fourth quadrant, that is from 180 degree to 360 degree. Refer to the earlier figure. Now we will define the resultant. Refer to the earlier figure. Here P and Q are the two coplanar and concurrent forces acting at an angle theta. Those two forces can be replaced by a single force whose effect will be same as that of the two forces together. This single force is called resultant of the two, is given by R equal to under root of P square plus Q square plus 2PQ cos theta, that in an earlier slide we have explained it. So I think now resultant concept is clear. Now equilibrium. If a body is at rest or in uniform motion under the action of a system of forces, the body is said to be in equilibrium. The necessary and sufficient conditions of equilibrium are: sum of the horizontal forces must be 0, sum of the vertical forces must be 0. And if in case of non-concurrent force system, then clockwise moment must be equal to anti-clockwise moment, or summation of moment also must be 0. The equilibrium is of two types, that is static and dynamic. Refer to the figure here. The body is kept on the ground, its weight is acting downwards and its reaction is acting upward. So total, the body is in static equilibrium, it is not moving. You must know that reaction and weight act on two different bodies, that is, weight is acting on the ground whereas the reaction is acting at the body. Hence they don't cancel each other, they will remain, because they are acting on the different body. Now dynamic equilibrium refer to an aeroplane, say flying at a 10 km height with a uniform velocity of 1000 km per hour. Now its lift is balanced by its weight and thrust is balanced by the drag. Hence the aircraft is moving and we say that it is a state of dynamic equilibrium. When there is no equilibrium, or then there might be an acceleration or deceleration, there may be a loss of height or gain of height. But when these four forces, that is thrust is equal to drag and lift is equal to weight, then we will say that aircraft is flying at uniform velocity and it is in dynamic equilibrium. Now static equilibrium, again refer to the figure. On the refer to the figure on the last slide. Here what we have done, there was a clock kept on the ground. It was in static equilibrium under the action of weight of the clock acting downwards and the ground reaction acting upward. Similarly, take the example of this ladder shown in the figure. It is kept against a wall, is under equilibrium under the action of floor reaction, wall reaction, frictional force at the ground and frictional force at the end, wall end at B, and the weight of the ladder. Consider an aeroplane flying at a height at constant velocity. Aeroplane is in equilibrium under the action of lift acting upward, weight acting downward, thrust acting forward and drag acting backward. It is the case of dynamic equilibrium since there is no acceleration or deceleration or no loss or gain of the height. Now conventional moment system of the lift, weight, thrust and drag of an aeroplane. Let us go beyond the syllabus. It is interesting, you must know all these things, because this is what an engineer should know and recognize all these things. When an aircraft is flying, refer to the figure below. Here you will find that weight of the aeroplane is ahead of lift. So there will be a counterclockwise moment due to lift and weight. So to balance this, thrust is kept below the drag line. Okay, why we do this? There is a logic behind this. In case of aircraft engine fails, if we maintain thrust and drag in co-line, in same line, and lift and weight also in the same line, then the aeroplane will not have a nose down tendency, it will fall like a stone on the ground. So, in case of engine failure, there should be a nose down tendency of the aircraft, so as it will get a velocity, and by that it will get lift. So it can get to a nearby runway or and land. For example, if we take a practical example, I will tell you now. This is Air Force aeroplane, IL-76, very huge aeroplane, having load carrying capacity of 50 tons. But if it is flying at 10 kilometer height and all the engine fails, it has 4 engines, then also it can glide for a distance of 300 kilometer, or within that distance there will be some nearby runway and it can land. So there is no chance that it can crash due to engine failure. So that's why these lift and that weight is kept ahead of the lift, and to counterbalance it, the thrust is kept below the drag line. So to balance this anti-clockwise movement, the thrust line is kept below the lift line to get the clockwise movement. Okay. Now equilibrant, very important concept again, but for that you have to first refer the how we defined the resultant. This is again parallelogram law of forces figure. Here resultant is given by under root of p square plus q square plus 2q cos theta. Now, as I had told you in the earlier lecture, that equilibrant is the force which is equal to the resultant of system and forces but opposite in the direction. Now, this is the equilibrium, that is minus R is the equilibrant force. So this equilibrant force will bring this system into equilibrium condition. Here this negative force is same in magnitude, line of action and point of application as that of R, but in opposite direction, orientation, that is called equilibrant force. Now here you must know that point of application need not be same, but it has to be on the line of action. Since body is rigid, so you can apply on the same line of action any force anywhere. So this system of forces, the equilibrant will be the force which will be equal to the magnitude of their resultant but in opposite direction. Okay. Now next. Now we will refer to examples. Now, for example 1, two forces of 100 Newton and 150 Newton are acting simultaneously at a point that will be what will be the resultant of these two forces if angle between them is 75 degree. Now, it is very simple. Just first draw a rough sketch OA and OB and at angle theta. The resultant is alpha. Then their resultant, it is a case of coplanar concurrent force system of two forces. Hence parallelogram law of forces can be applied here. Given the two forces are given, P 100 Newton, second force Q 150 Newton, and angle between them, that theta is equal to 75 degree. Apply the parallelogram law of forces, that are equal to under root of P F1 square plus F2 square of plus 2 F1 F2 cos theta, that is 100 square plus 150 square plus 200 into 150 into cos 75 Newton. That comes out to be 200.67 Newton. Now angle of inclination with respect to OA is given by tan alpha equal to Q sin theta upon P plus Q cos theta. then when we put all data into this equation, then we find alpha equal to tan inverse is 1.043, that is, which brings out to be 46.2 degree. The angle alpha is read with respect to force P 100 Newton in the anti-clockwise direction, hence the resultant will lie in the first quadrant, in quadrant 1. Okay, now again let us recapitulate the equilibrium minus r. This is equilibrium r minus r. This is equal in magnitude, that is 200 Newton, on the same line of action but opposite in the direction to that of resultant, that is 200.66. it is given. Equilibrium, the force will be in equilibrium static or dynamic if an equivalent force is introduced, as in the above example we have introduced r minus r equal to 200.6 Newton. Thanks for watching this video lecture. Any suggestion can be mailed at drpskaushik@gmail.com for further improvement to the content and the presentation. Namaskar, Jai Hind, Jai Bharat. Thank you for watching.